everyone, we're going to find the domain of a linear, rational, and square root function. So here's your linear, there's your rational, and there's your square root function. So for the first one, we're going to do linear. And basically the domain means your x. What can you input into this x? So if you had x values here, what numbers can you put in here to get your output of y? And we want it to be all real numbers. So we want to say that x is all real numbers. So basically this sign here means belong. You draw kind of a C and put a line. I do double line here and write R. We want it to be all real numbers. So are there any restrictions is really what you're asking. Is there anything I can't put in for x? And the answer is no. So your domain really is all real numbers. Another way to write this would be that x is in between negative infinity and infinity. It can't equal infinity because x is infinity is not actual a number, so it can't ever equal. It's just a concept. Or you could write it like this: negative infinity to infinity. We want it to be all real numbers. So when you think about domain, think you want it to be all real numbers. All right, now in this one, we want it to be all real numbers. So we want this to be all real numbers. We do have a restriction here, though. It can be everything but one number. And the number it can't be is 5. Because if you have 3x plus, let's just plug in 5 here. If I plug in 5, I get 3 times 5 plus 2 divided by 5 minus 5. That's going to give you 17 over 0. You can't divide by 0. There's nothing times 0 that gives you 17. So when you divide by 0, that means it's undefined. All right? So that means that it's all real numbers, but x, and this means such that, this right here means such that x cannot be 5. So if you divide by 0, that's like going in 3 dimension. You divide by 0, that's like going down the drain there. So just remember you can't divide by 0, but we want it to be all real numbers. Now another way to write this is negative infinity to 5, and then 5 to infinity. That means it can't include the 5. Oh, and you put a union here. So that means unites. Okay? So that's this is your interval way to write it. And this is your set notation way to write it. All right? Next one. We want it to be all real numbers. Can it be? So we know when we have the square root, we know that square root of 0 equals 0. You know, square root of 1 equals 1. Square root of 4 equals 2, and so forth. We could even do square root of 3, which is 1.73. But what we can't do when we're talking about the domain with real numbers is that x can't be less than 0. For example, if I put negative 1 in there, remember that's I, well that's a complex number. So we can't use that. So this quantity inside here has to be greater than or equal to 0. It can equal 0, but it has to be greater, has to be positive. So what I'm going to do is set this to be greater than or equal to 0. I subtract 1 from both sides, and I get x must be greater than or equal to negative 1. So that's your domain. All right? So it's all real numbers such that, or you can say but, x must be greater than or equal to negative 1. Okay? And you can kind of just look at it and tell that we can have 0 or bigger in here. Okay, this is your set notation. So interval notation would be like this. It can equal -1. So use closed interval here. And then it can just get bigger from there. And this would be your interval notation. All right. And that's it. Thank you. Have a nice day. Bye-bye.